Good evening, and once again, welcome to YouTube channel, Pearson International the Excel Math by Mitakamoto. And we are still talking about algebraic methods. This is the first topic of Pure Mathematics 2, and we'll be looking at methods of proof. Why do you need to prove something? And of course, we are saying that a mathematical statement can be proved by exhaustion. It can be proved by exhaustion. Exhaustion is where you break, this means breaking statement into smaller cases and proving each case separately. Exhaustion, we exhaust everything. We break the statement into very smaller cases and proving each one of them. And we have an example. Like we are being told, for example, you can prove that the sum of two consecutive square numbers between 100 and 200, the sum of two consecutive square numbers between 100 and 200 is an odd number. And of course, you ask yourself, what are the square numbers between 100 and 200? We have 100 itself, which is 10 squared. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And of course, beyond there, we have 15 squared, which is far beyond 200. When we talk about two consecutive, the sum of two consecutive square numbers between 100 and 200 is an odd number. Can we try it out? We may even start with 100 plus 121, which is 221. This is odd. We can talk about 121 plus 144, which is 265, which is odd. Now we are using exhaustion. We are breaking this information into smaller cases and dealing with each one of them. Then we have 144 plus 169. Of course, the last digit is a 3. It's going to be an odd number. Specifically, it's going to be 313. And let's talk about 169 plus 196. Again, the last number digit is 5, which is building to 3. This is also an odd number. The sum of two consecutive square numbers between 100 and 200 is odd number. So this is true. What is true? It's true that the sum of two consecutive square numbers, the sum of two consecutive square numbers between 100 and 200 is odd. This is what we have just proven by exhaustion, because we've been able to break this into smaller cases and dealing with each one of them. And of course, this method is better suited to a smaller number of results because exhausting means breaking into smaller parts and arguing each one of them. So if you have big data or many activities to do, then you are going to take a lot of time. You cannot, for example, to statement as one example is one case, but let us just look at example. Let's just look through example 15. And example 15 is asking us to prove that all square numbers are either a multiple of 4 or 1 more than a multiple multiple of 4. This is what you're supposed to prove, or rather, prove that all square numbers are either a multiple of 4 or one more than a multiple of 4. And that's what we're supposed to prove. I mean, all square numbers. We first of all need to say, is that number odd or is that number even? Let's start with odd number. Odd number. A square of an odd number. 2n plus 1, whatever the value of n is an odd number. So if you square this one, then you're going to have 2n plus 1, 2n plus 1. You square out, open the brackets, 4n squared plus 2n plus 4n plus 1. You realize that 4 is common in the first two terms. Or rather, you can talk about 4. We have n squared plus n. The reason why we did not bring n outside is because we are so much interested in 4 being a multiple. So this one is, this part is already a multiple of 4 because it can be divided by 4. It's a multiple of 4, you can see that. And because when we have now, when you add 1, then it becomes an odd number. It becomes 1 greater than a multiple number. So this one is already, the whole of this is 1 more, this one now, more than a multiple of 4. And therefore, it qualifies. It's proving our statement to be correct. Let's now talk about even number. Even number. An even number is just like 2n. Of course, we know that one is even. 2n squared is 4n squared. This one by itself, due to the existence of this 4, is a multiple of 4. And therefore, our statement is true. Our statement is true. Therefore, it's true that square numbers are either it's true that square numbers are either a multiple of 4 or 1 more than a multiple of 4. And that is just what we have been able to show. So next time, be on the lookout and subscribe further so that we can work together. All right.